Hi, welcome to our yearly 402 graduation project. Our project is named Electronically Configurable Antennas. It means that we can direct the RF signals to the wanted direction, like phased array systems. But unlike the phased array systems, our antennas are not always active. The beam direction is controlling with activating different configuration of antennas. A pin diode has an undoped intrinsic layer between p-type and n-type regions, and that's making it ideal for RF switching elements. It's used for high-speed RF signal control. In the reverse bias, pin diode stores charge and acts like a capacitor, and in the forward bias, pin diode acts like variable resistor. We have switched on and off the antennas with our pin diodes in the single pole, single drop configuration. The inductor blocks the RF signal from reaching the DC port, while the series capacitor blocking DC offsets from affecting the RF signal. And also, eventually, the resistors are used for controlling the currents at working limits. We have designed a feed network for 1x4 linear dipole antenna array. The impedance is matched to 50 ohms at the input and output of the feed network.
In this project, we designed a 1x4 linear dipole antenna array operating at 2.4 GHz. The distance between antennas is set to lambda by 4, which is approximately 3 cm. This spacing helps maximize parasitic effects, allowing us to achieve beam steering. In the design, we integrated pin diodes on PCB to switch between active and passive elements. The active antenna radiates the signal, while the passive ones act as parasitic elements, steering the main lobe in the desired direction. This approach provides a cost-effective and efficient way to control signal direction. During testing process, we used GNU Radio Companion for programming the ADA and Pluto SDR and reading data from it. GRC allowed us to control the SDR, enabling real-time data transmission and data collection. This setup was essential in ensuring the accuracy of our beam steering performance and validating the overall design. In this flow graph, we used a signal source to generate 1 kHz cosine signal and Pluto SDR sync as a transmitter, Pluto SDR source as a receiver, and Qt GUI sync to read data from SDR. To evaluate the performance of the design, we conducted various tests for different pin diode configurations. We placed the antenna array on a 45 cm radius circle and took measurements from different angles. By opening and closing the pin diodes in specific configurations, we observed the beam steering capability. In our measurements, we observed a maximum gain of -11.3 dB with the main lobe directed at angle of 0 degrees at 0001 configuration. At 0011 configuration, we observed a maximum gain of 4.3 dB with the main lobe directed at angle of 67.5 degrees. At 1111 configuration, which all the antennas are active, we observed a maximum gain of -1.16 dB with the main lobe directed at angle of 90 degrees. We performed our tests in non-ideal environments and interference from surrounding 2.4 GHz signals, and we experienced reflections and interference in our results. However, the test results showed that we could successfully change the signal direction and different pin diode combinations.